Hello, everybody. Thank you for coming to Beckhoff Webinar Wednesdays. Sorry, I'll get this right here eventually. I'm Matt Prowitz. I'm the Drive Technology Product Manager for Beckhoff USA. This is one of our series on advanced motion. This is one of the last that you'll see this year, but we will have one more coming up this year. It will happen in December, and we'll have information about registering for that event here later. You will be able to ask questions during the presentation. We will have a Q&A section at the end of the webinar, and the question window is the question mark comment section on the top. But I will also have our advanced applications group in the background answering the questions as we go through the presentation. So with that, I'd like to get started here. And we will have a short pause for about 1 minute as more people join here.
Advanced motion. Maybe we should have looked at calling this basic motion as well. So advanced and basic motion webinar is probably a better suited title for this conversation. Because what we're going to do is we're going to take a look at the path of using Beckhoff technology in motion applications. We're going to talk about the tools you can use for the motion application to select the correct drives and motors that you need. We'll talk about the available motion hardware, and we'll understand the software we use to integrate all those motion components with I/O technology, with your HMI. And during this, I'll have tips that you can use in your application. I'll try to directly call them out as we work through this, but we'll also talk about the trends we see from customers using our hardware and our software for their machine control. And we'll end this with some new product updates, including software and hardware. When you have a motion application, you have two paths. There's a hardware path and there's a software path. Some customers of ours have sent the hardware path to mechanical engineers and the software path to a software or controls engineer. What's nice about the Beckhoff technology is both paths can be worked from the mechanical engineering aspect and also from the software aspect, because the software can be developed away from the machine and it can be integrated back into the hardware when it comes to applying the motion product. So let's take a look on why you need a software tool to understand which components to use from Beckhoff. So let's go down the hardware path. The hardware path is a wide range of products. We have servo motor products and rotary servo motors themselves, so servo drives and servo motors. We have cabinet-free solutions. We have compact drive technology, stepper technology, linear technology, and hygienic motors, along with electrical cylinders. So if we take a look at what a machine is, you can see there's multiple areas of a machine. Sometimes there's an extension that is added, a cabinet that is integrated into the machine, and with this we offer the solution for each one of the points, because maybe there's a stepper motor needed in the application. So for this, we have our AX technology, which is a servo drive that's installed into a cabinet. It goes all the way up to 120 kilowatts with the AX5000, and a very easy to install AX8000 technology. That's a multi-axis solution, and each one of these options can control different motor types. There's no limitation of the motor type in which you want to use for this. And a very important aspect is the integration for safety. And so with this technology, we offer 17 safe operation modes up to a safety level of PLE or PLD, depending on what you need. Each one of these drives has a single and a dual channel aspect to it, and they're very easy to work, integrate directly into your control system. And with this, we offer motor solutions. Now we offer a standard motor product up to 15 kilowatts in high and low inertia. We have the IP69K hygienic design, and we also have electric cylinders that can go all the way up to 25 kilonewtons worth of force. We are coming out with a water-cooled motor as well. That'll go all the way up to 40 kilowatts of continuous power. And we offer linear motors for high speed and high force applications and with high dynamics as well. And we also offer stepper motors. The stepper motor is one of the aspects from our compact drive technology, but we also offer servo motors, and the servo motor can go all the way up to 1 kilowatt. We integrated capacitance for regenerative power for high dynamic applications, but the compact drive technology offers servo, stepper, DC, and brushless DC motors. We have cabinet-free solutions as well. And with that, we have also integrated the 17 safe operation modes for the motion application. That even includes safe brake control. The last hardware I'd like to cover is the distributed servo drive technology. This is a cabinet-free solution in which we integrated a 24-volt power supply. We offer a voltage range of support for single-phase AC power or three-phase power all the way up to 480 volts AC. A really nice benefit of the distributed servo drive technology is the one cable automation. This one cable automation is one cable that passes 24 volts motor and drive power and EtherCAT communication to the distributed drive on the machine. Now, this integration of the 24 volt power supply allows you to integrate the I/O technology in the IP67 cabinet-free solution and also bring in the 17 safe operation modes with the EtherCAT communication. This allows you to really seamlessly integrate the distributed drive technology into your machine. So when you look at this, go back and look at the machine, we have a servo drive, stepper drive, a servo motor for every application that is on the machine. And where to start with, how to select this, is with our Motion Designer software. The Motion Designer software is a calculation-based software. There's 4 main areas that we're going to talk about. One is the mechanical load case, what's useful for entering the mechanical information, a motion profile, a component selection section, and one of the most critical areas, the regenerative power in the motion application. So let's start with the load case. The initial configuration starts with a DC link. This is added at the start of the project, or it can be added during the sizing, because maybe you want to look at a different drive type. And then what you do is specify the voltage and then the drive type you want to work with. The next is the load case. There are 7 different rotary axis mechanical load cases you can work with. Electric cylinders and linear motors are integrated as well. With this 7 different load cases, you can analyze conveyor belts, spindles or ball screws, or rotary tables and racket pinions as well. Very general load case where you enter the inertia as part of this, and winders, unwinders as well. Whenever you select a load case, what you have to do is enter your mechanical information, and this can be tricky. Sometimes all you know is the thread of a ball screw, but we offer orientation setup. So here you can configure the orientation, whether it's a horizontal spindle or ball screw, or a vertical ball screw, or a variable, so a more complex mechanical system. This is just a pull down menu, and you can select which type you want. And sometimes what is not known about the spindle is what the inertia is. Or maybe you're not quite sure what the load mass is, but you know the dimensions. So we put in some built-in calculators that help you figure out what your inertia is, because that affects what motor you want to use, because maybe it's a high precision application, or maybe there's just unknowns, but you know the mechanical information of what you're working with. And then you can add the load mass. This is a different structure, but you enter the dimensions, the material, and then you get an estimated load mass calculated for you as well. And the units can be standard or imperial. Another aspect for sizing an application is the efficiency. We offer a quick configuration for the mechanical efficiency, because maybe your friction in the system is a rolling friction or a sliding friction. All have different inefficiencies in the system, and you want to account for them because they will affect the motor's performance. And sometimes there's efficiencies just for standard mechanical devices, because maybe you know that you're working with a roller screw. Maybe you're working with a ball screw. Those have known efficiency calculations, and we offer a simple pull down. But even if you do know these calculations, because you're getting them from, you can manually enter these values as well. The motion profile section is very helpful. It allows you to descriptively mark the type of move or the move command. Maybe you're moving up, maybe you're going to pause at a loading station, or maybe you're going to move to another known position. So it's easy to label and describe what you're adding. And then there's different types of moves. So you can do a distance, or maybe move at speed, or maybe you need to dwell at some of the areas. And then the type of move or the move profile in which you are trying to accomplish, you can use the traditional half or third, but you can also add a cam profile into this. And there is the jerk limiting motion controls, and you can import a CSV file if that's needed as well. And when you enter this move information, so I want to go to position 0 and take 1.5 seconds, you get to see what the dynamics are for that system. And so you can now specify the acceleration and deceleration and the jerk that you would have in that. And so now you can really add the custom motion profile for your system, because that is going to matter when you select the drive. In addition to that, we allow you to enter your process force. Maybe there is a pressing application, or maybe there's a part being loaded, but only loaded in certain areas and then unloaded. So not effectively the continuous mass in the application. You can put those in where you would need them to be placed. The component selection is one of the most critical areas. You can enter transmissions, so you can add different gearing and different couplers that you have in the system. You can actually import those as well. And what we want to focus here on is being able to select the right components. So let's look at that. The component selection area covers a gearbox and motor and a drive. When you look at the top part of this, you'll have the area in which you can jump between the gearbox, motor, drive, and you can also look at the thermal utilization. When you look at the motor area, there's two main areas that we need to focus on. One is the S1 area. This is the continuous range, so the motor can run all the time in this area. The intermittent area is where the application may require to go into, because the accelerations or the decelerations require higher current than the rated values of the motor. Now this is an intermittent range. The continuous range can't be there. Now where you find the continuous range is when you enter your mechanical information, your motion profiles. What you'll see is an effective application point. This is the little blue square that is pointed out here. And the most important thing about the effective application point is it needs to be within the S1 area. Now, if it's at the top of the S1 area or at the bottom of the S1 area, it's just a safety margin that you may want to use. I like to shoot for the middle, so a 50% safety margin on the application. The application curve can be within the S1 or the S5 area, but it can't be outside of it. And this application curve is the blue line that is drawn in the results here. So when we look at this example, this motor is perfect for the application. The RMS point and the application are all within the S1 area. This provides us a large safety margin for the motor selection. Here's a different example. This motor will not work in the application, and there's a couple of areas of concern. The RMS point is out of the S1 area. Reminder, the S1 area is right here. If we look at the application curve, this is also outside of the S5 area. The S5 area is the max area in which the motor can perform. Now the application curve is well outside of this. And a reminder, this is where the S5 area is, which is in the red boundary, and the S1 is in the green boundary area. So this motor just will not work in the application. We put a new feature in which we can compare two motors, because sometimes you can look at the torque and the speed utilization, because remember, we have a lot of safety margin, so maybe we can go down a frame size in the application, and then we can really see how the torque and the speed are utilized. And you can see there's about a little bit of an increase in the safety margin ratio, and with that we can analyze the precision, because the inertia will change too when we go to a different size motor. Typically we like to shoot for a 1-to-1 and a high precision. That really gives you less tuning effort, but typically the customers are looking at a 1-to-5, a typical precision application. Not critical, but critical is what they tell us sometimes. But some customers are doing a great job keeping things mechanically compliant, so the mechanical pliancy of the system is very well maintained, and they've also maybe slip a little bit on compliancy on the mechanical side, but lower the dynamics. And with this, you can go over a 10-to-1 or 1-to-10 inertia ratio on your mechanical side. We even have some applications that are 200-to-1 on the inertia ratio in the system. So one of the neat features of Motion Designer is understanding the regenerative power. So we do a complete analyzation of the motion profile for the regenerative power it generates. With that, we will see the effects of the motion profile with the internal capacitance of the drive. And we will also see what the in-feed power is, which is the internal energy that the drive is storing for the motion application, but also if it needs to dump that power off. So this never happens, right? We come up to an application and we see we sized it and no external regen power is needed. Sometimes things change, and what if we come into this and they want to change the dynamics and lowering of the ball screw? So we want to get to that lower position quicker. Well, if we do that change, we can easily add the change to the motion profile. We can now see that we have a lot of regenerative power happening when we're lowering the ball screw. We can see that in 2 points here. So what is that regenerative power doing? Well, the internal capacitors are being fully loaded. In Motion Designer, we can see that here, and we can see that here. And what we can also see in this area is that the regenerative power needs to be dumped. In addition to this notification on the charts, you can also see the exclamation points here saying there's not enough power in the system. So how do we address this? We go back to the system, we add a change where we want to dissipate that power. So we're going to change the resistance connection to external, and we're going to add a regen resistor to the system. Now the regenerative power is being handled with an external braking resistor. So the exercise of working through Motion Designer, entering the mechanical, entering the motion profiles, selecting the components, you can directly see what the regenerative power is in the system. Now, working through this, there has to be some benefit, right? So now when we look at the servo drive and motors, we can see we can create reporting. So you can do an easy full report. This will include the complete bill of materials. It'll offer links to the drawings, so if you want to download those. A short report, so less, more compact report, but it does include the bill of materials. You can just export the bill of materials. And one feature I really like is a documentation folder. It includes the full report. It also includes the step files and documentation of all those components. And during the process of working through the Motion Designer, all the parts you select are verified for compatibility. You will be notified if something is misconfigured or the component is a little bit too big or too small for the application, or you have regenerative power concerns in the application. The report is a PDF and can be easily shared. It will include who sized it, what was it for, the parts list, the application overview, the detailed on the axis report, and all that is part of the Motion Designer export reporting feature. And when this selection is completed, what you have is all the components. So you can see the power supply, the axis module, you get the full part number that is meant for the application, whether you needed a brake, high inertia, and the proper cable to select to connect that motor to that drive for the system. And with this, we will look at the installation, because it's worth noting how easy and how clean our installs work. But let's pause. I have to share a story of when I was working my initial days as a product manager for Beckhoff, and this is what I saw in the cabinet. I was helping out with the system, and we were struggling getting the drives to communicate into our TwinCAT software. The drives were EtherCAT compatible, but we couldn't communicate to them. So I'm like, oh, we got to look. Maybe the drives, maybe a fuse is blown, a circuit breaker's tripped. Popped open the cabinet, wires fell out of the cabinet, and I had to take a picture of this. And I looked and I looked, and I was like, where do we start? How do we know which cable is the right cable that's connected back to the PC? So we had to spend a lot of time looking at it. We found that the drives weren't plugged in properly. We saw that the cable that was unplugged was actually the communication cable, and some of the cables were looped back onto the other cables, and some of the 24 volts was miswired, and a lot of time spent just trying to communicate to the drives. This is why we do what we do. Here's an AX8000 system. We have an IPC, PLC, we have a 24 volt power supply, and then we have the drives. We run a single cable to the drive for the field bus connectivity, which is EtherCAT. We run 24 volts to the drive. Now, this is important. There's a single point for the electrical protection. This is one fuse that goes right into the drive. We have internal filters in the drive, so you have to use a fuse with that. It saves you money by not needing a mains filter or a mains choke in the application. The AX bridge technology is something customers are just extremely happy with. It is a easy, fast, toolless connection to bridge in the access module to the power connection. 24 volts EtherCAT and a high voltage DC power is supplied to the access module. It is a slide over, click down, and one cable technology out to the servo motor. So not an additional feedback cable. The feedback cable isn't incorporated into the motor cable. It is truly one cable technology to the system. So here is how fast an AX8000 can be installed. Bring in the power supply, snap it into the back plate. bring in the axis modules to the system. Here you can see the AX bridge technology slide over. It's really nice. It has some places where you can actually make it stay, which makes it very easy to install onto the system. You slide the bridge over, you connect the potential shield bar, you bring in the power connector, you bring in the field bus connector, and you're installed. So you can really see how clean and how easy it is to install there. And again, very, very simple, very, very compact, very, very easy to electrically protect. Right, we've talked a lot about hardware, but there's another side of this. There's the software path. And this is the TwinCAT Motion product. The Motion product is very wide range. It can control multiple axis types. It can control a stepper, hydraulic axes, a servo axes, linear motor, a rotary. It can control a torque or a VFD. It can do robotics and kinematics. It can do the coordinated motion around those applications. And we can do interpolated motion with a complete CNC and XTS and X-planar functionalities built into the TwinCAT Motion software. So when we go back to the two paths, now let's look at the point-to-point kinematics and the CNC. Why TwinCAT Motion? It's based off the abstraction principle. The power of EtherCAT has made this even more powerful. But when I first started as an application engineer at Beckhoff, the PLC code that I developed back then is still the same today. And over 25 years of development based off of PLC motion control standards has made it very usable and expandable from when the field bus changes. Because when I started, Circos was the main drive control field bus. Now it's EtherCAT. But I've done Profibus, DeviceNet, and I really, really see the benefits of the determinism of EtherCAT. So it's the bus for motion control. It can do all the way up to 255 axis. I'll give you a kind of a tip of where to start with the different platforms, but it has extendability for more complex operations for camming, flying saw, external set point generation for unique algorithms that you might have. The nice thing is I can develop here at my desk because it's fully simulated. TwinCAT measurement integrates right into it, so you can really see how the motion and the motion control and the PLC are synchronizing. We have examples that you can download today that shows drilling operation, how to do a print roller phase shift, and also how to do position correction on a conveyor belt as well. This is the abstraction principle that I keep talking about. The PLC is the commanding, is where I issue my commands, but also where I enable and I stop. That is developed for an axis. The numerical control side, the MC2 side, is where the set point generation happens. So how to get from point A to point B of the axis. So you can have a Beckhoff servo system, but you can also use a Beckhoff stepper drive, XTS mover, X-planar mover, and also maybe an analog drive or a step and direction drive can be added to the system. And all that can change on the I/O side because the field bus, it is a field bus driver. But as the technology changed over the last 20 years, the code that I developed for a Circos drive hasn't changed for an EtherCAT drive. So very easy to develop something today because it's going to be supported in the future. You have to have a scalable platform. So you may have a basic application, which we can put you in performance level 30, and it's a very good point-to-point application. So here is a processor that fits to your application, but maybe we need to extend the performance. We need to go up a level because now we need to do camming or flying saw, or maybe we need to go to performance level 50 because now we're doing kinematics or we're doing CNC. All of it is scalable. to the different platforms, because maybe the number of axes is growing in your system. So now instead of 3 axes, I want to do 75 axes. So we can put you in the right performance level, and that code that you developed, that controller that you used, is scalable up. There's no changing the coding or anything like that. The functionalities that you develop are still usable in your larger processors. Here's an application in which you can use, so just some highlight points. So the PLC issues a command to the NC, and then the NC sends the set point generation out to the drive. These cycle times can be down to 62.5 microseconds for motion control. The status information of the drive is something that is asked about. I try to enable my drive, I get an error. So here, this is a very important feature where you can look at the my axis status and am I valid or not? If you are false, the axis is ready for operation. If that is true, because IO data is invalid, the axis isn't ready. You would look for that to be false, and then you would enable your axes. So you can really real-time monitor the axis at any point in the application. You can read the torque, you can put that back into your application. You can issue move commands in which you can specify the dynamics and really make it blend well in your application. And you can read the error and the drive diagnostics in real time. You can put that into the HMI, put suggestions on what is causing the error. And we offer a full supported function block for all of our axes that is available. Just contact us. And now when the programming is completed, we offer more benefits. So now this is the process that EtherCAT works very, very well. So the EtherCAT allows us to just connect in the RJ45 cable to the drives, use our Drive Manager 2 software to configure the Beckhoff servo drives, which sets up the scaling. It configures the speeds for the application based off of the voltage into the drives. It'll help tune the axis, whether you're manually tuning or running auto tuning for it. The auto tuning does really help if you have complex mechanics. You can apply the notch filters or biquad filters in the system. TwinCAT measurement is very well integrated into this, and Motion Designer projects can actually be used to help set up the configuration. A new feature for our TwinCAT HMI users is that we now have an NC-P2P GUI that you can drop in for your maintenance modes in the application. If the application is running, this GUI does not interfere with the motion application. TwinCAT measurement is a very, very useful tool, and what you can do with it is monitor the lag, actual set points, velocity, really important things on the motion control side. But on the PLC side, it can really help you debug your PLC code. You can see when you initialize a command and when a command the move is complete, or the command isn't just happening the way you expected it to. So you can really see that. With this, here's an example of working tuning and axes of a system where we run our auto tuning. We looked at the mechanics of it. We see that we're very mechanical compliant. So we add the velocity observer to the application to improve the tuning, but you can see any spikes that are caused when we do this effort. But here it's very, very easy to tune in axes. And we have a new feature where you can actually smooth out the accelerations to really fine tune your motion control, because maybe you're accelerating a little bit too much and you want to back it off a little. And that's the power of TwinCAT measurement, because with TwinCAT measurement you can really understand in real time what your application is doing. And here the motion is complete. Now, we didn't have enough time to go into complete details. What we're going to do is we're going to follow up with you all on the Motion Designer ball screw example, how to set up the AX8000 STO, the ELM STO setup, and a detailed point-to-point with the ELM compact servo drive that has STO capabilities through EtherCAT for you. Look for those links to come. So, customers that are using our motion control. Pace Packaging has used our AX8000 technology for the unscrambler and orientation Omni line, where they've integrated a solution that puts the cabinet installation right into the machine. You can't even see the cabinets. Now, this really helps them speed up the installation because it's a modular system. The cabling design is very, very well done on this, and it reduces the overall space for these components by 75%. They've implemented preventive maintenance and real-time monitoring, which really increases the machine performance. So right there, very clean install for the machine. Another application was with CMD. This is a flexible tension punching machine for bags. They utilize our TwinCAT motion to accomplish this with camming and point-to-point. And they utilized our AX8000 technology inside of the cabinet that makes it very, very clean. They used our high arc flash rating. They integrated touch probes directly into the drive, and the open design of the machine, they implemented safe limited speed and safe brake control with safe brake test to test out the safe brakes in the application. Cincinnati Inc. is another successful story. The new CLX laser fiber cutting machine from Cincinnati Inc. utilizes our technology. They utilize multiple sides. The field bus technology kept their infrastructure very, very simple. The machine was updated to newer technology, so more modern technology, better HMI, easier to install components, easier to synchronize because now the safety is integrated into the system. And this is all done with FSOE safety. And the OCT really simplified that connection of the AX8000 directly to the motor as well. Urbex is a storage retrieval system, a complete cabinet-free solution in which we used our AMP with 480 volts, but also our compact drive technology. They integrated our new stepper ASI technology, and this offered them a lower cost motion control solution that we call drive motion control for our lower end processors. So when we look at all of our customers that we just talked about, they all came back with a full integration of their application into one software package. It was very easy to install the drives in the cabinet, and their cost was reduced by 50% because of smaller cabinets, less cabling, a breeze to wire in and configure the system. The integration for safety, up to 17 safe operation motion control modes. Built-in diagnostics and performance monitoring so they can really see, is this drive, this motor, are we meeting the application specs? You can do that very, very easily. The drives are integrated into the HMI. You can export the drive history, so if you need help with supporting or troubleshooting an issue, it's easily done. There are advanced features built into the drive's functionality for collision detection, torque control, auto-tuning with BodyPlot integration, and EtherCAT is one of the main reasons why it's so successful. The Deterministic control, synchronization, the basic motion, and advanced applications are really what EtherCAT plays well in, and the simple integration is why those basic applications take a hold of it as well, because the monitoring and no topology limitations really help in a successful application. So some new technology for you quickly. Next year in Q2, we will release our new universal regenerative unit, the AX8820. This is a way you can take your regenerative power and put it back on the mains grid to help make your machine more power efficient. Our water-cooled motor is available now, and this will give you 40 kilowatts of power, very high power density, so that's the nominal output power. So all the way up to 240 Newton meters worth of torque, high dynamic application. It can be used in ambient temperatures that are a little bit hot. If you already have chilling on there, you can get a very, very powerful motor in there, and it's at about an IP65 protection rating. Electric cylinders are available as well. This is a very important aspect where the mechanical distance, and this is why this next feature is important, is we incorporate a motor file into the design. So when you scan in, not only the mechanical position or the mechanical limits of the ball screw or the electric cylinder is known, but also the zero position. So all you do is scan in the motor, automatically sets up the referencing for you and the travel limits of what the electric cylinder can go, so it won't over travel at any point in the application. Very, very powerful units. So 25 kilonewtons, 12.5 kilonewtons, and 6.25 kilonewtons, different stroke lengths all the way up to 250 millimeters. So what does this mean? Is you can pick up 2.5 tons with these cylinders, and they're very, very robust. So much that we even incorporated into our 48 volt technology as well. We're making stepper control a lot simpler, and we're offering a dual channel, low cost TTL feedback now with our stepper motors and our drives, and a dual channel form factor. And we're offering an integrated stepper. Both are available today. Very, very easy, very, very successful, getting great feedback from customers that are using them right now. We are evolving our TwinCAT 3, our TwinCAT motion control. And with this, a reminder, today you can do all the way up to 255 axes, but that's limited to one processor. That means one execution time and preparation task for all axis types. So if you have a very fast update, that means they're all running at there, and you have to do special configuration to slow that down. So based off the previous development software, so with that, the memory transfer is what it is, and so we need to make some optimizations. Introducing MC3. No fixed axis limit, multi-core support for the different processors that are coming out that you may be need to utilize. A simpler axis execution of preparation task, and as the architecture changes on the memory transfer, it is future-proof to that. What is important for you is nothing is going to change that is different from what you're used to today. You have a system configuration where you can see the MET, the motion execution, and the MPT, the motion preparation task for the motion control. You have the axis configuration. Not much is going to change there, but the information is a little bit different. One is an actual virtual axis, and the one that's more out bold is an actual axis, not a simulation axis. And the PLC is now an MC3 library. Nothing changes on the I/O side. The drives stay the same. Abstraction is still a core concept. So your PLC coding that you develop, the axis type that you are controlling, whether it's a hydraulic axis, is now all incorporated into one environment, and then EtherCAT going out to the drive allows you the abstraction aspect. The multi-core scalability is a very, very attractive benefit. So you can keep your NC2 task, which typically runs at 2 milliseconds, but maybe you have to add an XTS. Or maybe you have different tasks or different add-ins to the machine, which require different update rates. You can keep that all and put it on its own core assignment, utilizing the motion control across a multi-core environment. This means that if you have a modular project where you have a station filling or maybe a pick and place application or aspect to or maybe a kinematic robot that you don't necessarily want to update at the same time as your XTS, or maybe you need to update it quicker than the XTS, you can do that very easily with MC3. We expect to have this out next year, and we will offer more benefits for the motion control software. In closing, you can fully leverage the available Beckhoff hardware with Motion Designer. You can select the right motor for your application by entering your motion profile, understanding the regenerative power in the system, and you can modify the motion profile as it changes and see what the results are. You can install very, very easily the hardware, and it's not just the cost that we're giving for our components, it's your cost. You're saving 50% on the cost, 50% on the space savings, because you're going with smaller cabinets, less cables in the cable tracks. You're simplifying the installation and significantly simplifying the configuration, because it's all done in one software package and done on the machine online, not disconnecting and reconnecting softwares and cables like we used to do. It's a fully integrated motion solution. The cabinets, diagnostic, monitoring are all part of it. Safety as well. And it's one platform. Many scalable motion solutions, stepper technology, servo drive technology, rotary, linear, electric actuators as well, XTS, X-planar, and it's all driven from the TwinCAT XAE development. Drive Manager 2 is used to set up the servo drive products and the stepper products, and Motion Designer is used for selection of the proper motor and drive. More information can be found. Here's some quick links for you to dig deeper into the distributed AX8000 technology. And I want to thank you for your time, and I want to open it up to any questions.
Thank you, everybody. One second, I'm going to be transitioning here a little bit, and I see some questions in the chat. I want to pull up, go back to my presentation here, so 1 second here. Go back into the PowerPoint. Here's a link to the next webinar registration. Feel free to go there. I saw some questions that were answered. I got the okay that there's some answers. There's a couple of them that are popping up on the screen in front of me. Looks like we have one that wants compact motion support for the stepper technology. What I can tell you is I should have included this in the slide. Yes, we will have auto tuning and Bodhi plot support for all of our compact servo technology in the future. It will also incorporate our X motion products. That's the XTS and X-planar products as well. The next release of the auto tuning will have the support for the stepper technology, and then we'll incorporate the X motion products as well. I can't see that question. I am using the AX5206, 48 volts. Yes, right now to get access to the auto tuning feature, reach out to me or reach out to your your local applications engineer or sales engineer. Put the request in for the copy for auto tuning, and I'll work with you to get the auto tuning support on your system. MC3 is compatible with all motion control hardware in the future. It is taking the same drives, and you can control stepper, AX8000, AX5000. It is going to be supported only in 4026. So you would have to migrate to 4026 to get the support for MC3, Q2 for the release on that as well. All right. There are going to be some questions we will follow up with you on. We have all right. This question, do you have a good resource for the workflow for importing a drive into TwinCAT and controlling motion from a PC through NC point to point at a granular level? You can import the configuration into the TwinCAT project, and then apply your PLC logic to that drive without too much work. It's simply importing a file and then connecting it up. That we can definitely help you get connected on there. Yes, MC2 is going to be supported in 4024. So if you are using 4024, yes, you will have to use MC2. Licensing for MC3 will be defined at a later date. I can't answer that question today, but we'll follow up with we'll follow up on that one. All right. Okay. All right. So with that, if we missed any questions, looks like we have a new one coming in. Oh, just thank you. Yes, thank you. I appreciate the time for everyone this afternoon. And I want to say, reach out to us if you do have any questions. Most of you, we'll saw a lot of the questions came from customers I know. Feel free to reach out to me if you have any additional questions, or your local team for a more follow-up. Again, for the next webinar is on test and measurement, and that is December 11th. You can register here from the QR code, and it will be a very enjoyable, festive December webinar. And again, I appreciate your time here and look forward to future conversations. Thank you.